Okay, so roots are represented by exponents that are fractions. If you have a square root, you can represent the square root of a as a to the 1/2. If you have a cube root, you can represent the cube root of a as a to the 1/3. Are you seeing a pattern here? A fourth root is a to the 1/4. A fifth root is a to the 1/5. If you want to have something called an nth root, that would be a to the 1 over what? What do you think?
N.
Very good, Marissa. Very good, Kathy. 1 over n. Okay. So one problem with this page is that the numbers are pretty fuzzy. I'm going to help you fill in a couple numbers here. That's supposed to be 128 to the 3/7. That's supposed to be 14 to the 2/5. I think you can read the others. So the first problem is 4 to the 1/2. We said 1/2 is the same as what root? Yes, thank you, Danelle. The 1/2 exponent is the same as a square root. So this is the square root of 4. All right, so a lot of you guys, you see the square root of 4 and you just can't help yourself. You want to keep going. That's totally fine if you want to, but it didn't say that you had to evaluate it. It just said to write it in radical notation, so you can stop there. 125 to the 1/3, what kind of root is that going to be? Is it square root, cube root, fourth root? Cube root, very good. Okay. Next one, 128 to the 3/7. So this one has a numerator of 3 and a denominator of 7. The numerator is the power, and the 7 is the root. So when you see a fraction exponent, I want you to think power over root. Power over root. So which of those numbers is going to be the index, the number that goes in here? The 7, very good. So the 7 is the index, and then the 3 is the exponent. And actually it's going to be equivalent if you put the 3 here or if you put the 3 out here. It doesn't matter. You could put 128 to the 3 on the inside or 128 to the 3 on the outside. All right, so take a minute and see if you can do that last one there. Here we go. All right, so let's see if we got that one right. So your power is 2. Your root is 5. So you put the 5 in here. 5 is called the index, and 14 is the base, and then 2 is the exponent, and you can put that on the outside or you can put it right there on the inside. That's your choice. What questions do you have so far?
I have a question as well.
Yes.
What do you do if you get a negative exponent?
All right, if you get a negative exponent, we're going to get to that in 1 second. Okay, so power over root, right? So a square root, do I have to put the 2 in here? No, normally when you do a square root, you don't put the 2 in here. If you wrote it in there, it's not technically wrong, but it doesn't look right. And then that's going to be to the 3rd power. So now, let's see if we can, it says also that you want to simplify now. Okay? So what is the square root of 9? It is 3, very good. So now I have 3 to the 3rd. So that means 3 times 3 times 3, which is 27. Beautiful. All right, this fraction's hard to read. It says 125 to the negative 2/3. So Danelle asked a good question. He said, what happens if you have a negative exponent? Does anybody remember from our last unit what happens, our last lesson? You flip it. Okay, so where does it go? To the bottom of a fraction. Very good. So this would be 1 over 125 to the 2/5, or the 2/3, right? I'm reading that. That is definitely a 3 to the 2/3. Okay, so if it's not a fraction and you want to flip it, you can put it over 1 like that. 125 is the same as 125 over 1, and then when you flip it, the 1 ends up on the top. All right, so now I'm going to make this power over root. So I have a cube root, I have 125, and then I have squared. So I know you guys know how to do cube root on your calculator, but I love it when you can think it through without the calculator too. It's some number times itself gives you 125. Any ideas? It's not 2. 2 is too small, right? 2 times 2 times 2 is 8. Can't be 3. You can guess and check on the calculator, or you can go and do a cube root on your calculator.
5 times 5 times.
Okay, so Kathy and
That's
Mervyn both
125,
gave
right?
me 5, right?
5 times 25 is 125.
Right, so that's 5 times 5 times 5. So the cube root of 125 is 5. Thank you, guys.
Square is 25, right?
And then squared, thank you, Amin. So 1 over 5 squared is 1 over 25. That's our fraction. Who has a question on that one?
Why did we put the 1 over it again?
Because when you have a negative exponent, it's going to move to the other part of the fraction. And if it's not already in a fraction, you can make 125 125 over 1. That's equivalent. Okay? All right, Hussein, how are you doing with this? Did you get that one?
Yeah, I got it. Thank you.
Good. Okay. So now we're going to work backwards. We're starting with the root, and we're going to make it into an exponent. So remember, the exponent is power over root. Power over root. What is the base going to be? What's the base of my exponential expression? 7. That's right. Okay. Take a minute and talk to your group about whether our fraction is going to be 2 over 3 or 3 over 2. I want you to talk to your group about what it's going to be. That does mean that you have to talk. And it also means you have to have a group.
So, what do we think the answer is?
3.
Alrighty. Good talk.
What do you think right now?
Okay, what number should go on the top?
2.
The 2, very good. 2 is the power, and the root is 3. Thank you, Misha. So I have 7 to the 2/3. Excellent. All right, do B. Go ahead and write down your answer for B. All right, so B is 11 to what fraction? 3/5, that's right. 2, down here, we have 8, and we don't have an exponent, but we do have a 4th root, so we know this is what fraction? 1/4, thank you.
That's what you.
Okay, I need your help. Next one.
What's up?
11 to, I'm doing the last problem.
Oh, the last one?
Yeah, 11 to whatever what?
5 over 3.
5 over 3, that's good. Okay, do you guys have any questions before I turn the page? I decided not to evaluate it on the calculator because you're never going to be asked to do that, so I just took that off, okay? All right, let's turn the page then. Okay, here comes... Guys, here we're using the same exponent rules that we used before. If you multiply, you add your exponents. If you have a power to a power, you multiply your exponents. If you divide, you subtract your exponents. We did all of these rules last class, but now they're asking you to do these rules with fractions. Now, adding with fractions can be tricky. You have to find a common denominator, but you can also add the fractions on your calculator. So this is a multiplication problem. I need to add the exponent, so it's going to be x to the 2/3 plus 3/4. And you can add those with a common denominator, or you can add them on the calculator. So if you don't have a calculator and you want to grab one, do that, because adding fractions is much easier on the calculator. I'm going to do 2/3 plus 3/4. And then I get this, but I'm going to press math fraction. Math fraction. And I get 17/12. So this is going to give me x to the 17/12. All right, let's do another one. Let's do this one here. When you raise a power to a power, you multiply your exponents. So this is going to be x to the 1/3 times 5/4. Multiplying fractions is not as hard as adding them, so you might just choose to multiply that by hand. But if you want to, you can also do that on the calculator. So we're going to do parentheses 1/3 times parentheses 5/4. And then you get something like that, and then you press math, and you choose fraction, and you get 5/12. So this is going to be x to the 5/12. So what I want you to do is try to do the top part of the page. This one's kind of hard to read. This is x to the negative 1/3. Okay? Work on those. All right. So I'm recording again. Raise your hand if you want to explain how you did the second problem. I'm looking for a volunteer. That's right, Tati. So what'd you get when you subtracted your exponents? X to the 1/2. Very good. So subtract your exponents. 3/4 minus 1/4. You should get 1/2, which makes your answer x to the 1/2. Beautiful. All right, so here's another division problem. We're going to subtract again. Raise your hand if you got that one done. Anybody get that one done? It is going to be the same thing. Misha, what did you get when you subtracted them? Did you do it yet? Oh, I didn't hear you. I'm sorry. Go ahead. Oh, you got 1/2 again? Did you? Okay. Is that what you got also? Okay, so you both got x to the 3/10. I agree. So when you do 4/5 minus 1/2, you do get 3/10. That takes a little bit of common denominator work to do it without a calculator, but with a calculator it gets you that answer right away. So x to the 3/10. What questions do you guys have before we move on?
Why is it 1/2 in number 2?
For number 2? So in number 2 we subtracted 3/4 minus 1/4, right? Now if you're doing that without a calculator, you would get 2/4, and then you would change 2/4 to 1/2. All right. In the next problem, we're doing power to a power, and our rule says if you have, it's up here, if you have power to a power, you multiply your exponents. So we're going to multiply 1/3 times 4/1. 1/3 times 4/1, and we get 4/3, so it's x to the 4/3. And then the last one is tricky. The last one has a negative exponent, so when you do your reciprocal, put the 1 on top, put the x on the bottom, and that's going to change your 1/3 to a positive 1/3. So anytime you have a negative exponent, it switches the part of the fraction it's in, and it turns positive. Okay, so I'm going to pause for just a second, because some people have been waiting for that bottom part, so I can give you some new instructions for that bottom part. Okay, so we are doing a cube root times a cube root. If they are the same root, you can multiply the insides. So I'm going to multiply the insides, and I get the cube root of 64. All right, sometimes you get a cube root that you can simplify. So I'm going to use my calculator and see if the cube root of 64 is a number, if it's an integer. Okay, so cube root is not right here on the screen. To get cube root, you need to press math, and then you can go down to number 4 there. Hit that cube root, and then I'm going to put in 64. Do you guys already know what I'm going to get? 4 is right. Very good. Yeah, 64 is a kind of cool number because it has a square root and a cube root, right? What's the square root of 64? 8, and the cube root is 4. Beautiful. Okay. So this answer, this final answer, is just 4. Okay. Next one. They're the same root, so let's multiply the insides. I get cube root of what?
Shoot.
40 is right. You're right, Julissa. Thank you. Okay. And then I'm going to do cube root of 40 on here. What am I going to get? Anything good?
Wait, how do you 40?
I just multiplied 8 times 5. Okay, so I don't want that. All right? So cube root of 40, that's not helpful, but I'm going to do a factor tree. Okay? Factor tree. All right, any two numbers that make 40, what do we get? 20 and 2 will work. You can choose different, though. You don't have to do the same ones. 5 and what? 5 and... No. 5 and... Oh, you wanted to do 5 and 8 to start with. Yes, you could have done that. I'm going to do 5 and 4 right now, though. And then I'm going to do 2 and 2. So your factor tree doesn't have to look the same as mine, but at the bottom we've got 2, 2, 2, and 5. How many times does the number have to show up in order to take it out of a cube root? More than 2. What is it? 3. If it's a cube root. If it's a square root, it has to show up twice. If it's a cube root, it has to show up 3 times. So we do have 3 2's. That's good news. That means that 2 can live outside. So I've got 2 cube root. Remember, it doesn't turn into a square root, still a cube root, and I still have a 5 left. So that's your simplified version. Okay. Next one, I have a cube root and a 4th root. Do they have the same index?
No.
No, they have different indices, so if there's a different index, you cannot combine them. Okay? If you have a different index, you cannot combine them. So we say that's already simplified. So I'm going to give you a minute to try these problems down here. We haven't done problems like this, but you might still be able to figure it out from things you know from before. So I'm going to pause the video and give you a minute to work that out. All right, so in this problem, it's a division problem. We are really going to divide the insides. So we're going to divide the 162 by 2, and what did you get when you divided those? 81. So I have 4th root of 81. Does anybody know if that's going to be an integer or not?
It's 3.
All right, Danelle got 3. Did anybody else get 3?
Yeah.
You got 3? Do you guys know how to do a 4th root on your calculator?
Kathy knows. Kathy, why don't you tell the class?
Is there one like that? Math, then what? Oh, do I have to put the 4 first, though? Let me try it, okay? So 4, math, 5. Oh, that made a 4th root. That's really cool.
That's why I'm
All right, and then 81.
There's no way it's happening.
All right, so I get 3 also.
You don't got it. You got to still
All right, so I got 3 the same as you guys. For this one, I saw a lot of good work happening with factor trees. I saw 27 times 2. And then I saw 9 times 3. And then I saw 3 times 3. So the bottom part of your factor tree is 3 times 3 times 3 times 2. And which number can come out of your cube root? 3, because it happens 3 times. So I have 3 cube root, and what's left? Just the 2. Good. All right, and the last problem is an addition problem, and we hadn't done any other addition problems. So I want you to think about that. When you add like terms, you keep the like term, don't change it, 4th root of 3, and then you add the coefficients. So 2 plus 7 gives me a coefficient of 9. Well done. Okay, so this is it for today. I do have more practice for you if you need that, or if you have a math assignment on MathSpace, we can do that too.
I work on a